see the output matrix, you also have direct transmission matrix. In the rigid body motions, you have zero output matrix, and you have the same the input matrix. Okay, why is that? Why in the rigid body motion you don't have this term? You have only this term. Anybody tell me why? Where does this term come from? Where does this come from? This is vibration motions. What do you mean vibration motions? Vibration motion, we have this, then we have this U. Where is this K? That's because we have spring. Spring got force to M, and this is another force to M. So because you have a spring force here, so you got not C terms. Okay, now you got to be careful of this. The states, what we mean the states? States. My states, XC, X equal to WV. That's the state. This is state vector. This we call state vector. That state vector includes only displacement and velocities. How come my state don't include the W double dot? It's W double dot. How come W double dot is not in there? So only W dot in there. Why? Anybody tell me? Huh? How come a state vector only have a W and V, and that means V dot? This V is W dot. How come I can have a state vector will be W double dot W double dot? Can I do that?
No, because in a state space when you fix that vector, it will be zero triple dot.
Well, sounds good. The simple question is, does W dot, and W, they are not all independent. Only two independent is W and V, and W and W dot. This is not independent because this one can solve from here and there. Agree? So, only two independent states. That's W and W dot. W dot and we can solve from here. So the state vector only includes independent quantity here. Okay? Understand? So that's why the measurement, if we want a measurement, include only the independent quantity, the W and V, then C has to be only like this, 1, 0. If you have Excel measurement, you can say, okay, I have Excel measurement. If you want to write the Excel measurement in terms of the state space model, like a Cx plus Du, then your C will be this, your D will be this. Okay? That's just one way to express your acceleration measurement will be the dependent, will be the function of the state and U. Understand now? So, I think the best way to do is to memorize the physics rather than the mathematics. It's easier that way, so you won't forget forever. Right. So, if you understand about this, then we know that because displacement measurement, you measure the W. That's the independent state. The velocity measurement, you use V, you measure V, that's the independent quantity. For XL measurement, that's W double dot, that is not independent quantity. If you want to write in terms of independent quantity, then you have to write C and V like that. That is the state space model. So that again, this is my state space model. That's a vibrational motions. Now, if you look at this, what is the eigenvalue of this? The eigenvalue of rigid body motions are 0, 0. The eigenvalues of AC, what is that? That's supposed to be the frequency of the system, right? So, the eigenvalue of this will be the eigenvalue of that will be what? K over M I plus or minus I. That's my eigenvalue. Agree? If you understand, I'm going to show you 3 important motions. If you understand the 3 important motions, then later it will be easy for you to design a controller. Because I don't just talk about in math. Alright, so this is, that's what's going on. Now, let us look at the next. Another one. Vibration motion with damping. That's even more interesting. Again, let's just note this. Okay, I'm not going to erase this, alright? I'm going to change this. We just keep adding the term. This is with damping. Alright, you need to rewrite this. I'm going to just change this. With damping. And then I need to change this guy with damping. Plus. For that, with damping, then this is will be M inverse there. And BC is the same. Interesting, right? All the motions. Doesn't matter if it's in civil engineering, in mechanical engineering, or in electrical engineering, all the system motion, nothing but these 3 different motions. Okay? And that's my state matrix. That's my input matrix, the same as this body motion, the same as vibration motion without damping. My displacement measurement, because they are in the independent state, the same thing. or this. The velocity measurement is independent quantity, the same, like this. However, this is different. Alright, let's see. Why don't I do this? Let's see. What is this? Y, because you might not be able to see it, so I have to be careful. Y equal to W double dot equal to that there minus M inverse K W minus M zeta M inverse zeta W dot plus M inverse U that we can write in terms of minus K over M minus Z over M, then WV plus M inverse U, right? So now my C. That's my C now. And this still my D. So in a rigid body motion, C is 0, 0. In a vibrational motion without damping, we have a minus K over M0. In the vibration motion with damping, then we have minus K over M, minus 0 over M. That's my C. Then we have du. So, doesn't matter if it's rigid body motion or vibrational motion or vibration motion with damping, then it's displacement measurement, velocity measurement, always got no D. So if anybody show you a measurement equations, if somebody show you a measurement equation that has no D, that for sure that measurement won't be the axial measurement. Understand?